Thought I'd make a quick video about this microwave oven. It's a Panasonic NNCD9895. I've been pretty happy with it, but it has blown out the high voltage boiler twice. This oven features a built-in convection oven. You can use it as a toaster oven if you want. There's a few downsides about this. The first biggest one being, just to run that clock, requires 22 watts of electricity from the wall. That's a lot of power for running a clock. The older units only needed 3 watts with the green screens on them instead of the blue. The other problem is I've blown out the control board on this several times. Technically my wife has. I don't think she had enough load in it, and for some reason they don't hook up a high voltage diode to ground backwards, which would let the 2.4 gigahertz travel through that off the high voltage on the magnetron. When it gets standing waves, it'd let it go to ground, where simultaneously blocking the DC that it uses to power it. This is common practice in several other units by Panasonic, but not this one. It's a very nice stainless steel unit. I'm going to probably make some modifications to the high voltage board next time it dies and try adding in that diode to ground, because I don't really want standing waves when it doesn't have enough load killing it again. As you can see, it's a pretty nice unit. The high voltage board is down here. It's elevated about this much to prevent bacon grease from getting on it from the vents, but it still gets bacon grease on it if you go crazy with the bacon, so it's better to not even put bacon in this unit. This is a 1.6 kilowatt unit, which pretty much maxes out a 15 amp circuit. If you fit the wrong high voltage board to it and you modify the connector to fit, you run into this issue where it draws 2 kilowatts instead and burns out the high voltage board really quickly. So just keep that in mind. If you start mismatching parts together, this unit tends to become a lot more powerful, and it can boil water in several seconds, but it also has the downside of burning itself up quicker. The convection oven is particularly nice in this. Oh wait, that's combination for running the microwave and the convection at the same time. So you can do broil or bake. Usually I do bake. And I'll set her at 350 for 45 minutes. If you run it at full temperature and you put it up to around 480 to 500, eventually it will actually go and overheat, and it has a thermal cutoff that shuts it down. Oh, hi, Justin. It's a very nice unit, and I'm very happy with it. Just thought I'd show this off. It's really easy to fix when it breaks. Just remember to discharge the high voltage by clipping off a connection to ground and then taking your screwdriver and touching it. You can also use a resistor if you want to do it right, but I prefer to use the screwdriver to ground method, even if it makes a little bit of a spark.
Yes.
Thank you. One more problem I forgot to mention. This door. See how it's got a little bit of a wiggle to it? Well, that gap is big enough when you pull on it, the 2.4 gigahertz can escape. And if you're running the microwave oven, you can notice that it'll trip your GFCI breakers in the general vicinity of it. Initially, it took me about several months before I realized why I was getting GFCI trips, and eventually I realized it was when the microwave oven was on. But I also realized it was knocking out my Wi-Fi. So naturally, I eventually figured out that if I held a fluorescent light bulb right here, that the gap in the door was what was causing it to happen. Once I realized that the 2.4 gigahertz transmissions on around channel 8 were occurring while the microwave was in operation. It didn't seem to affect the lower half of the band at all. The output's actually surprisingly clean from a cavity magnetron meant for cooking food. I don't know if it's like that for all brands, but it is for the Panasonic. So remember, when you have this issue, it's caused by the plastic dowel in here. You can't really see it. There's a plastic dowel that goes into this very heavy-duty hinge. The older models had a piece of steel. At some point, I'm going to change it out. But yeah, all you have to do, if you're running into this issue, and it's more pronounced when it's on an uneven surface, is just simply take a piece of duct tape, like so. Put it there, and then make sure the door is closed all the way, and it won't leak any noticeable amount of RF out of it. Thank you. One more thing I decided to include. You can see it's not very well insulated in a few spots for the convection. That's At some point, I'm going to stick Roxol in where it's leaking the most out of the sides and the top. But it is insulated with fiberglass insulation, but I'd rather use Roxol since it has a better R factor. But you can see there's a bit of emissions out of the door. Nothing too serious. And you can see where all the hot spots are. Yes, Justin. I'd show you the other side, but there's not too much where the high voltage side is. It mostly leaks into around where the high voltage board is. Justin's gonna open it up and turn off the convection apparently. But yeah, that's basically it. This doesn't have enough insulation. Yes, Justin. At some point I might do a video about my thermal eye. I mainly just use it for stuff like this to see where there's leaking. Infrared's really neat. It's a lot closer to microwave spectrum, so it does all sorts of fun things. Thank you.